Hello class, this is lesson 6-5 in your textbook titled How to Solve Special Types of Linear Systems. So we've been solving linear systems, and so now I'm going to show you two different ways. So we'll have three different scenarios that you might see. The first is called a consistent independent system. That's the one that you've been working with all along. The second one is an inconsistent system, and the third is a consistent dependent system. So with the ones that we've been working with already, there is one solution, okay? And when we were graphing this, I'll move this up just a little bit. When we were graphing it, we found that typically the two lines would just intersect. And wherever they intersected, that was your solution, right? It was that coordinate of the point where they met. And so what we found is that these two lines in the system will have different slopes. So let's write that down. Okay. For an inconsistent system, there's not going to be any solution at all. And you might be wondering, well, how is that going to happen? Well, typically, if you have two lines that are parallel, they're never going to meet, which means that there's no solution. They're never going to intersect. Okay? So what we're going to see in this case is that the two lines will have the same slope, but they're going to have different y-intercepts. And then for our third case, the consistent dependent system, it's going to have infinitely many solutions, which means you're not just going to find one solution, you're going to be able to find countless solutions because it's going to be one line on top of the other line. They're going to be the exact same line when you graph it. And so what we're going to find here is that they're going to have the same slope and also the same y-intercept. All right, so write that down, and then we're going to go ahead and do a couple examples right now. So here we go. When you're going to solve a system, you're going to have different options, and so you're going to get a lot of practice of doing different ways today in class. And so you can either graph them and just look at what the graphs look like, and that'll tell you maybe if it has a solution and where it is, or if it doesn't have any solutions. Or you can use substitution or elimination like we've done before. So for our first one, we're going to go ahead and graph it and try to see if we can find out what the solution is. So I have 3x plus 2y is equal to 10, and I also have 3x plus 2y is equal to 2. So already I see some similarities in here. If I was going to graph it, for me it helps to rewrite them in slope-intercept form. So I'm going to rewrite it. The first one would be y is equal to negative 3/2 x plus 5. This is by moving the 3x over and then dividing by 2 to get the y alone. So when I graph that, it's going to be crossing the y-intercept at 5 and going down 3 and over 2. And then I'll be able to connect my two dots to form my line. Perfect. Let's rewrite the second one. When I get the y alone, I'm going to have negative 3/2 x plus 1. So I already see that it has the same slope, but this time it's crossing at 1, and it's going to go down 3 and over 2. And then when I draw my line, look at that. It is a parallel line to the first one. And so what we wrote down before was if they have the same slope but different y-intercepts, then we're going to say that it has no solution because they're never going to meet. The other way that you could have done this was by either substitution or elimination. I'm going to do elimination. So I'm going to line up both of my equations. And I see here I can just subtract that bottom line. 3x minus 3x is 0. 2y minus 2y is also 0. And 10 minus 2 is 8. and you can see that 0 does not equal 8, so therefore it's inconsistent. It has no solution, and I got to move that up for you. There we go. All right, let's do one more and then we're going to be done. I have two more equations for the system. 4x minus 2y is equal to 8, and also y is equal to 2x minus 4. So one of them is already in slope-intercept form, so let's go ahead, let's go ahead and figure this out. So I have -4, so I'm going to plot that down right here, and I'm going to go up 2 and over 1 and draw my line. Awesome. And then if I'm going to rewrite the second one to get the y alone, you're going to find it's going to be the exact same equation. So if I'm graphing it, it's going to be the exact same thing, which means that this is going to have infinitely many solutions. And that would be my answer. You could have also solved this a different way. If I wanted to do substitution, I would write down my first one. And because I have what y is equal to, I'm going to take this and I'm just going to substitute it into that first equation. So I'm going to rewrite it, 4x minus 2 times 2x minus 4. That's what y was, is equal to 8. So let's go ahead and work this out. 4x minus 2 times 2x is -4x. -2 times -4 is +8. And 4x minus 4x, that cancels each other out. So you just have 8 is equal to 8, which also means that it's going to have infinitely many solutions. So on your own, I just have two problems that I want you to try. I want you to tell whether the linear system has one solution, no solution, or infinitely many solutions. I don't want you to actually solve it. And so you can look at the slope maybe, or you can look at the y-intercepts, and that should bring you to a conclusion whether or not it has one, no, or infinitely many solutions. So I will see you when you come to class.